Welcome back, folks. Chapter 2, Lesson 2 for Kinematics. We are going to start with a nice, easy warm-up example, and then I've only got one other example in here, but it's a little bit more involved. But let's not worry about that for now. Let's try a nice standard, let's call it that, kinematics question. So here we're dropping a rock, a Dwayne Johnson, dropping him from a building that's 24.5 meters tall. And we are asked, how long does it take the rock to hit the ground? So always with these kinematics questions, we want to start with our list of variables, the VFDAT list. So VI, VF, DAT, what can we put in there? Well, we start with no initial velocity. We're simply sort of holding the rock out over the edge and then just dropping it so it starts from rest. Final velocity, we're not asked to find it. We're not given that value. We just don't really care. Displacement, you have to be a little bit careful. Remember that the rock is falling 24.5 meters. Displacement is a vector, so direction matters. So you do have to catch that negative sign in there. Acceleration, the question doesn't tell us that either, but we know that it's just gravity, so it's negative 9.8. And we're looking for time. We've forgotten our stopwatch, but we want to calculate it instead. So we head to the formula sheet. We grab a formula that doesn't have a final velocity in it, and we get this one. Now, what I want you to do is sort of look at the numbers you're going to plug in before you do so, and it turns out we can actually make part of this equation disappear, which is really nice. That initial velocity of 0 multiplied by anything means it's gone. And a really common mistake that students make, it's a surprising mistake actually, is they think that 0 multiplied by something is still something, but it's not. All right, 0 times t, it's gone. So really we're left with d equals 1/2 at squared. That's all we've got. So that's kind of nice. Remember, this term is out. I wouldn't even show it, to be honest. Plug the numbers in that we've got. I think the first thing you'll want to do algebraically to solve for t is just deal with this right here. Let's just multiply the 1/2 by negative 9.8. It's a number that shows up a lot, right? Half of gravity in this equation. So that comes out at negative 4.9 t squared. Now we need to solve for t, so divide both sides by negative 4.9. You get a nice number, you get 5. That's actually not the answer, that's t squared. And then we simply take a square root. Do remember that all square roots technically are plus or minus, but you can't have negative time. This is not Superman where you can go fly against the rotation of the Earth to go back in time. Time always moves forward, so we just take the positive value. 2 or 3 sig figs plus units, time of 2.24 seconds. So there's a nice warm-up question, standard kinematics. Most questions will be of this difficulty level. Let's try one more example in this video, a little bit more involved. We're going to up the ante. So here we're throwing a rock upwards, not regurgitating it, but just physically throwing it into the air. And it leaves our hand at 31.36 meters per second. We want to know when this rock will be 39.151 meters above the ground. Kind of strange looking numbers, but they're actually pre-cooked like a hot dog to make life easier for us. You'll just have to trust me. As you can imagine here, we've got some like magical line in the sky. Or like a really tall power line or something at 39.151 meters above the ground. And we want to know how long it's going to take for that rock to get up to that magic point in the sky. So first things first, always with kinematics, start with your VFDAT list. In the last example, we said there was no initial velocity. We were dropping a rock off of a building. This time we're throwing it upwards. That 31.36 is our initial velocity. Final velocity looks like it's still the one that we're going to cross out. Doesn't give us that value, doesn't ask us for that value, so don't really care. They give us the displacement. It is positive this time because the thing is going upwards. We know acceleration is gravity. Remember, it's falling upwards initially, right? It's slowing down. Eventually, it's going to come back down. So gravity is always negative. we need to solve for t. So just like the last example, pick an equation without VF. There it is. D equals VIT plus 1/2 AT squared. Now, as we go to plug values in here, we, or you, might realize that there is, I'm doing air quotes here, a problem. And the problem is we're going to end up with a couple of t's in a couple of places. So 39.151 equals 3136t plus 1/2 AT squared times negative 9.8 times t squared. So we end up with this t into t squared, and it turns out they're not like terms. Because one is just a single t and one is a t squared, you can't just combine them. So what we actually need to do is go to our formula sheet. So here's the back side of the formula sheet, bottom right hand corner. When we run into this issue where we're trying to solve for a variable and the variable squared and we can't combine them, we actually need to use this, something called the quadratic equation. And this might be new to you and it might look kind of scary, but I promise, at least in Physics 11, pretty darn easy. It just looks scary. Again, trust me. The quad formula is another short name for this. Only works if you set up your equation like this. We don't have x's, we have t's. So we want ours to be something t squared plus something times t plus just a number. A, B, and C represent just numbers. X's are going to be our t's. We need to set it equal to 0. That's key. And if we do that, then we can figure out what our A, B, and C values are, and we can carry them over and use that equation. So let's go back to the notes, back to our setup here. What we need to do is get this thing set equal to 0, but actually the first thing we should probably do is simplify a little bit. Let's again multiply the 1/2 by negative 9.8. So that's going to give us 39.151 equals 3136t. Half of negative 9.8 is negative 4.9 t squared. Now we need to set this thing equal to 0. So you've got a couple of options. You could subtract the 39.151, move it over to the right-hand side, or you could grab these two terms here and move them to the other side. And it doesn't really matter. I think let's just grab the 39.151, subtract it from both sides. That'll give us a 0 over on the left-hand side, which will work great. Now keep in mind this 39.151, it's not a like term with the 4.9 t squared, and it's not a like term with the 31.36t. So it's actually just going to hang out there. And what I want to do is set this thing equal to 0. That's how we set up this quadratic equation. And I'm going to list my t squared term first. It's nice if you can put that one first. So I've got this negative 4.9 t squared. So I want the t squared term in there first. Then I want this singular t. And it's positive, so there's a positive 31.36t. And remember, we can rearrange. It's like 2 plus 3 and 3 plus 2. It's the same thing. And then we've got this negative 39.151. It's almost like a constant term. It has no variable attached. So that's how you want to set this up. T squared, then a t, and then just a number. And if you're willing to do that, then what you've got here is the number sitting in front of the t squared, and you have to take the sign with it as well. That goes into the equation as a. The number sitting in front of just the singular t, that's going to go into the equation as b. And the number with the sign that is sitting by itself with no variable attached, that's going to go in as c. Oop, sorry about that. So now let's take the a, b, and c and plug it into our quadratic equation, which again looks scary, but it's really not that bad, trust me. So it says this, x equals, I'm going to change it into t equals because we have a t instead, not that it matters. It's negative b plus or minus the square root of b squared minus 4ac all divided by 2 times a. And it might look like this has got uncertainty. You see this plus minus and you go, what? That's kind of like chapter 1 uncertainty. But it's actually not. We'll see what we're going to do with that in just a moment. But let's go and plug the numbers in. So t equals, here it's negative b. So it's going to be a negative 31.36. And I do want to point out that if this b term up here had actually been negative to start with, then we'd have negative 31.36, and it would actually turn into a positive. So do watch your plus or minus signs when you decide what your a, b, and c are. So that's plus or minus the square root of b squared, which is 31.36 squared. I would recommend putting that in brackets in your calculator when you square it, because if you don't and it's negative, it's actually going to give you a negative answer, and that's not what we're looking for. Students know that a negative times a negative is a positive, but when you type it into your calculator, you're technically only multiplying a negative by a negative if you put it in brackets. And let me just really quickly show you that. Negative 31.36 squared. If I don't use brackets, I'm telling my calculator, take the negative answer of 31.36 squared. If you actually want to square a negative, you have to put it in brackets, then close the bracket there, then square it. Now it's a negative times a negative. That would be the kind of thing we're looking for. So do make sure that you put things in brackets, especially if they're negative. So minus 4 times a, which is negative 4.9, times c, which is negative 39.151. That's kind of long. I got to extend that. And it's all divided by. So that fraction bar covers everything. And then it's 2 times a. 2 times negative 4.9. Now, that's nasty looking, right? But it cleans up really nice. Again, trust me. It's just scary looking, that's all. It's like Mike from Monsters, Inc. So what we need to do is I would recommend tackling this part first. Maybe not even with the square root, just the stuff underneath the square root sign. That's called the discriminant. You may recall that from math. And if we can type that into our calculator in one shot, then it's going to simplify it for us and make this look way less scary. So negative 31.36 plus or minus the square root of. Now let's try that on the calculator. Again, all of that's going to get typed in. You shouldn't need any special brackets or anything like that. I will put the brackets on the 31.36 because that's a good habit. But that's the only thing I'm going to have to do. Minus 4 times negative 4.9 times negative 39.151. There you go. So that's before the square root, 216.09. Divided by, we might as well multiply the 2 times negative 4.9. That's going to take us back to negative 9.8. And you can see in one step that became much less scary. That looks way more manageable, I think. And now let's take the 216.09 square root of that. So it's negative 31.36 plus or minus. Square root that answer. 14.7. All divided by negative 9.8. Now, it's not an uncertainty. What this is actually telling us to do is it wants us on one hand to do an addition. So it's saying, please, to solve for t, take negative 31.36, add 14.7, and then divide by negative 9.8. And then it's saying, hey, on the other hand, go and do a subtraction. It's kind of weird. We're going to get two answers. Negative 31.36 minus 14.7, all divided by negative 9.8. Be very careful that when you type this in your calculator, don't let the wheels fall off right at the very end. You've done a great job up to this point. You have to put brackets on the addition and subtraction if you want it to happen before the division. So watch that in your calculator. Scroll down a bit, let's try it out. So it was negative 31.36 plus 14.7. All in brackets, there it is, divided by negative 9.8. Looks like a 1.7. And then on the other side, we're going to do the subtraction. Again, watch those brackets. Negative 31.36 minus 14.7, bracket that up, divide by negative 9.8, 4.7. So we get two answers, and now we have to sort out which one is the answer. And the answer to that question is yes. What? What's going on? No, Mr. Heinrich, is it 1.7 seconds or 4.7 seconds? Which one is it? Yes. Here's what I mean. If we sketch a little picture, hopefully you can see this. It's actually pretty cool. So here we are on the ground. We've thrown a rock up into the air. And we want to know when it passes this magical mark in the sky of 39.151 meters above the ground. And we get two answers. Maybe you can sort of figure out what's going on. What happens is when you throw that rock, you give it a nice big toss, it goes up, hits maximum height, comes back down. And so what the math is telling us here, and it's really cool that it can do this, is it says, hey, you pass that magical mark in the sky at 1.7 seconds when the rock is falling up, and then it hits maximum height. Now it starts falling back down, and it's going to cross that magic line one more time at 4.7 seconds. So the answer is, which of those is correct? Yeah, they're actually both the right answer. So that's pretty cool that you can actually have two answers to one question. Now, you are going to see a question like this on the Chapter 2 test. This is something you are responsible for in Physics 11. And the questions that you need to do, let me just open up worksheet number 5. I'll show you which two questions are